doing right now? Get into this daily routine here. Okay, that's not the daily routine. What did you get out right away? Your reading book or your Chromebook? Thank you. Everybody's here. Okay. Let's see if I can fix my screw up from earlier. Go to third period. Go to this week. Number 8. Go to this lesson right here. Done that. Again, click on it up here. Okay? Put your name in. Mine already thinks I've been in, which is fine. There we go. That's what I screwed up last period. I got second period's link in third period, and third period's link in second period. I think that's what I did. Everybody signed in? Okay, we're going to be talking about similar polygons today. Here's your learning goal. That you can determine whether or not two figures are similar. And we are going to talk about similar here next. Similar polygons is just another way of saying scaled factors. Scaled factors. Scaled figures. That's what similar means. And we need to talk about proportional. Remember what proportional means? Anybody willing to give it a guess? Tell me if these two fractions are proportional. What do you think? Computer says no. Anybody else? Take your headphones off. What did I multiply by here? 2. But what did I multiply by here? 2. Are these fractions equivalent? This fraction's over 1, but what happened to this one? Okay? In order for two fractions to be proportional, they have to be equal. So because I chose a different multiplier for my denominator, those are not equal and therefore not proportional, not similar. Okay. Wait, the next part is yours, Ms. Butters. Okay.
Okay, so you're going to do 7.1. Choose whether each of the following statements is true in all cases, in some cases, or in no cases. If two figures are congruent, then they are similar. So I'll give you some time to think.
So you're going to pick an answer, and when you pick an answer, it's going to pop up with a box. And then you're going to fill in that box. You're going to type some words in there. should pop up if I go to the yeah, if I got them in the right section, which is yet to be determined. They should pop up with their answers here. But if anybody submitted yet, go ahead and hit your blue box if your answer's done. Last time I got my links messed up. And then are you ready to submit? Share with class?
Okay, does everybody know what congruent means?
We've talked about it.
Yes. Okay, can you tell me what congruent means?
It means like all the sides of the figures are equal.
Right, in both of the figures. Did everyone hear that?
Apparently I still am not going to see their names.
Okay, so we'll just go over this one. So if two figures are congruent, then they are similar. Who wants to answer this one? What did you put for this one?
I put they are congruent because we are similar because they have the same angles, and congruent means they have the same angles and sides.
Right. So you're saying for every single case. That's true.
Yes.
I would agree because, okay, let's say we have a square right here. So we know in a square all the angle measures are the same. And the side lengths are 4, 4, 4, 4. So in a square, the side lengths will always be the same length. And then congruent means we have the same exact figure over here. So same angle measures and the same side lengths. Okay, so to be similar, we need to have the same proportion, right? So we have 4 over 4. We have the same angle measures. So that's similar, right? So, okay, good. So yes, every single case, that's true.
Okay, next one.
Okay, so choose whether each of the following statements is true in all cases, in some cases, or in no cases. If two figures are similar, then they are congruent.
What do you think? If I ever get this link thing figured out, it'll be a small miracle.
Yeah, that'd be really helpful.
It would be. It worked first round. Didn't work second. Hasn't worked third. And I checked. My guess is because I didn't copy the link correctly. I think I thought I did. My guess is if I look, they're probably all in first period. That's my guess. Well, maybe not. Nope, that didn't work either.
everyone finished? Someone still working?
That's fine, you can go ahead and start making it
Okay.
working, so.
Okay, so if two figures are similar, then they are congruent. Yes.
I'd say in some cases,
Okay, why would you say in some cases?
because to be similar, they have to have the same angles, but they don't have to be the same size.
Right. Okay, good. So yeah, so if we had an example, let's just use a square again. So you're saying that they have the same angle measured,
Right.
but they have different side lengths.
So like, yes.
So we use 4, 4,
Yeah.
4, and then pick the side lengths for the next one.
8.
8. Okay. Yeah. So you're telling me these are similar because they have the same proportion. So they have 8 over 4 for
Right.
each of the sides, and they have the same angle measure. Good. So that's similar, but not congruent. Okay. And then there's an example when we have them being the same exact figure, which makes them similar and congruent. Okay. Okay.
Next one?
Yep. Okay. Choose whether each of the following statements is true in some cases, true in all cases, or in no cases. If an angle is dilated with the center of dilation at its vertex, the angle measured may change. Does everyone know what this is asking? Okay, so you might have to help me out with this one, but
Yeah. It means if you use, say, a scale factor of 2 on this figure, the angle measure also multiplies by 2. Is that true? False? Or, well, actually, sometimes, always, never? What do you know about your angles when you dilate a figure?
Okay, is anyone still working on this? Okay. Emma, what did you say?
I said no cases.
No cases. And why did you say no cases?
Because the angles will stay the same.
The angles will always stay the same. Good. Yes. So in every single case, the angles will stay the same because we're just focused on changing the side lengths. When you change side lengths of things, it doesn't change the angle measure, right? No. Okay, it doesn't change the position of it. Okay.
So this 60-degree angle, even though I use a scale factor of 2, is not going to become a 120-degree angle, correct?
Correct.
Okay, good. All right, we got Priya and Claire.
Okay.
Priya says,
Sorry.
no, you're fine. We're beyond the warm-up. Sorry.
Oh, this is beyond the warm-up?
This is beyond the
Okay.
warm-up. Priya says these polygons are similar because their side lengths are the same. They're all 2. Claire says they're not similar because the angles are different. Priya right? Claire right?